1 minute again. Afif. Seakan gue bonge ini. Bonge ngantuk ini. Udah, sekarang waktunya ya. Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, my student of class mineralogy, class A, and good morning to Dr. Mohammed Abdallah Raswan Atia from National Research Center Egypt. Yeah. Alhamdulillahirrahmanirrahim. Today is the visiting lecturer program for session 2. Yeah. For mineralogy class A after midterm. Yeah, with a visiting lecturer of Dr. Mohammed Abdallah Raswan Atia from NRC Egypt. But before starting the presentation by using the video, because in the check net I get that trouble, so I give request to him to give me the video. Yeah, I start now. Sorry. Sure. Yeah, okay, yeah, it is to remind us. This is about a visiting lecturer program 2026 batch 2, ya, skema B for mineralogy class A. With title in my proposal, it is utilization of rock mineral for manufacturing of functional material. Ya. And now we arrive at this session, ya, session 2, Wednesday, 3 of June 2026, with the title of visiting lecturer. Visiting lecture is physico-mechanical properties of cement with rock mineral as additive and substitute. Yeah. This is to remind us about our responsibility in this collaboration, that me as the host, I have the responsibility to prepare the paper for publication and for publication process by me, and I am the main author and corresponding author. And Dr. Mohammed Abdallah Raswan Atia have the responsibility to give the visiting lecture for 200 minutes, yeah, and also as the co-author in our collaborative publication, yeah. And thank you very much. I pray to Allah. I hope give the success to Dr. Mohammed Abdallah Raswan Atia, and success for me and success for all my students, yeah. Amin ya rabbal alamin. Okay, I start ya. And presentation. Share sound. Share sound. Share sound. Saya man iso ya sendiri. Okay.
Raswan, Assistant Professor at Geological Science Department, National Research Center, Egypt.
Can you hear clearly? Okay. Bisa dengar kan ya dengan baik ya?
Bisa, Ibu.
Ya. Oke ya, alhamdulillah. Saya lanjutkan.
The current lecture will deal with the physical-mechanical process of cement. Cement is a neat cement without addition or without substitution, or cement with additive materials or substitution materials. And we will deal also with the characterization method of cement calibration and examples of characterization and interpretation. First of all, I would like to throw light on some important topics. Hydration of cement. The cement, in its nature, in its powder nature, don't bind the fine and coarse aggregates. So how can it bind the fine or coarse aggregate in concrete, for example? It should react with water. Such reaction called hydration of cement. The hydration continue as long as favorable conditions are provided or are available. Like moisture must be available in the condition of the reaction, temperature, or we call curing temperature, and also space or voids that enable the hydration product to be produced or to be accumulated or precipitated. Any hydration reaction in chemistry must include three items: input, output, and if these reactions are indeterminate or external. Firstly, the reaction of cement or the hydration of cement had a product which we call hydrates. And these products we call like CSH, CH, and so on. And these products are the skeleton or the infrastructure of hardening cement paste, which make the paste or make the concrete or mortar or paste be stiffness and hardening. So when Portland cement, for example, mixed with water, the paste or the resultant paste begin to be stiff. Stiffness meaning hard, meaning the particles will be sticking to each other after period. And after period, strength is developed. Firstly, setting, initial setting, final setting, and finally development of strength. Strength meaning strength high, meaning porosity low, meaning density high, meaning durability low, and so on. The second item of hydration is the heat of hydration. Any reaction or some reactions in chemistry may be endothermic or exothermic when the reaction with water. In case of cement, the hydration of cement or the reaction of cement with water is exothermic reaction. What meaning of exothermic reaction? It liberates amount of heat, which we call heat of hydration. The amount of this heat, of such heat, depends on several factors, especially type of cement and amount of major compounds in such cement. For example, as you know, the cement is composed of mainly of four major compounds like C2S, C3S, C4AF, and C3A. And each one of these compounds liberate different amount of heat. For example, C3A liberate the highest amount of heat during hydration, about 516 PTU per IP. PTU meaning British thermal unit. And the lowest one is C2S, which liberate 98 PTU per IP, per pound. Several types of cements, like as shown in the second table, show different amount of heat with time, with age. From the first lecture, you know that type 1, type 2, 3, 4, and 5, meaning several characteristics. Each one has several different characteristics. For example, Type 2 is the moderate sulfate resistance or moderate heat resistance. So the amount of heat that will liberate from this type of cement will be low, 47.5 kilometer per gram. And type 4 is the low, not moderate here, no, meaning low low heat of hydration or low heat cement. So type 4 is the lowest, the type of cement that liberates the lowest amount of heat with time. The rate of hydration in reaction in chemistry may be finished instantaneously or immediate period or immediate time, or may take long time or forever. In the cement of hydration of the cement, the hydration of the reaction of cement with water in the early age would be faster, and the rate of hydration decrease with time. Several factors affect such rate of hydration. The rate of hydration are influenced by several factors, such as phase composition of cement. For example, C3A reacts with water instantaneously, faster than the other phases. As you can show in this figure, C3A by blue color will react fastly or more fastly than the other components. The second factor affecting the progress of hydration, the rate of hydration, is the fineness of cement. The more fineness of particles, meaning the high surface area of cement, the logic conclusion, and then the high rate of hydration in contact with water. For example, type 3 cement type 3 is meaning rapid hardened Portland cement. Why we call it rapid hardening? Because it's high fineness particle, high surface area, and such surface area or such fineness has also a great effect on the strength gain. This table shows the effect or the influence of cement fineness on the strength gain with time. You can see that with increasing fineness of cement, the strength gain increase with time and with increasing the fineness of cement. Third factor, the water cement ratio. The increase in water cement ratio will increase the degree of hydration, especially at the early age. Temperature or curing temperature. The rate of hydration increase when increasing the curing temperature, providing no drying will occur. Will occur meaning evaporation of water. Other factors such as chemical admixtures. In concrete production, we use some admixtures according to the conditions or air conditions. Are we in hot conditions or cold conditions? Are the space or the distance between the plant or concrete plant to the project, the distance is too long or too high or small condition or low distance. For these conditions, the contractors use some chemical admixtures. So, for example, calcium magnesium sulfonate we use as a retardant. Retardant meaning inhibitors or decrease the rate of hydration. Such as gypsum. Gypsum, as you know, coated in the cement manufacturing to control the flush setting of C3A phase. Other mixtures like calcium chloride can be added in the concrete or cement or added to cement as accelerated or fastening the hydration of reaction, especially in the cold weather. Some additives like polystyrene slag, by ash, fillers, any type of pozzolana, calcium pozzolana, natural pozzolana, rock materials, any other type of additives can affect the amount or the rate of hydration. Age or time. You know, the hydration rate is maximum at age. And with time, the process of proceeding in time, the rate of hydration decreases with time. In reaction, maybe divided in three periods, or maybe divided in several periods. In the reaction of cement with water, such reactions are divided in three periods. And such three periods are related to the engineering practice. The engineering practice, first one, workability period. Workability period meaning in practice spotting or wetting the concrete mixing, transporting, agitating, placing, and finally finishing the concrete mix. All of these parameters must take place in such period, which maybe take from 1 to 3 hours. The second period is a setting period. Setting period here, the cement start to thickness or start to of the hydration start to be low. And this reaction is the accelerating period. Accelerating period, what means accelerating period? It takes more times, from 10 to 20 hours. During this period, the curing of concrete, as you know, after molding, the concrete or the steel product must be cured for complete hydration and for development of the strength. During this period, the concrete are cured and can be extended to the next period, which is called hardening period. During this hardening period, or we call it deceleration period, the period all the hydration is shared, and the strength development takes place in such period. So, such period maybe take after the demolding or decasting of the concrete product, the concrete mix. After decasting, the strength development will take place. The strength development meaning the decrease in porosity, meaning decrease in durability, meaning increase in bulk density or density, meaning decrease in porosity, decrease in water absorption of such product. Hydration product. In reaction must be finally liberate heat and liberate end product. What the end products or what the products of the hydration or reaction of cement with water. Three main products in the reaction of cement with water. First one, calcium silicate hydrate, CSH. Calcium silicate hydrate, such phase or such product occur during the reaction of C3A, C2S and C3S with water. For example, C3S, tricalcium silicate, 2 mole of tricalcium silicate react with 6 mole of water and produce 3 mole of calcium silicate hydrate or CSH plus 3 mole of calcium hydroxide. Dimole of dicalcium silicate layers will react with 4 mole of water and produce 3 mole of calcium silicate also plus 1 mole of calcium hydroxide. The difference between these two phases is the amount of portlandite or calcium hydroxide. The amount of portlandite liberated from the reaction of tricalcium silicate with water is triple the amount of calcium hydroxide or portlandite liberated from the reaction of dicalcium silicate with water. CHS in total research make about 50 to 60% of the volume of the solid in case of in the complete hydration of cement. The other percent represented by calcium hydroxide, which is the second hydration product. And such phase or such product consists about 20 to 25% of the volume of the solids in hydrate. And this phase may be decreased or maybe still in the place maybe decrease. How can the calcium hydroxide decrease? If we add some additive materials like especially inorganic materials, inorganic materials react with such phase calcium hydroxide to liberate again CSH. And calcium hydroxide has a main advantage or characteristics, especially for reinforced concrete. How can this phase help or can be helpful for reinforced concrete? The alkaline nature of such phase, which maybe around 30, inhibit the concrete or help the concrete to be corroded, especially for reinforced corroded by sulfate attack or any other attack medium. The last one or the last hydration product, calcium aluminate hydrate. Calcium aluminate hydrate, such product occur during two reaction steps. First reaction steps occur between the reaction of C3A, water, and calcium sulfate. Calcium sulfate, the source of calcium sulfate from gypsum or from other source of sulfate. For example, calcium sulfate from gypsum react with C3A phase and water and forming the most famous product, ethylene calcium sulfate, calcium aluminate sulfate with high amount of water, 32 mole of water. So, after the reaction of the calcium sulfate with C3A, if the calcium sulfate is already consumed, all the amount of calcium sulfate, for example, gypsum, it's stored in gypsum. It's consumed from the first step, but not all C3A are hydrated. Some other C3A or some other modes of C3A or parts of C3A is still present in the mix. The ethylene that liberated from the first step will react with C3A, the remaining with C3A in the mix. And the addition of water, forming monosulfoaluminate or low sulfate ethylene. Why low sulfate ethylene? Because the amount of sulfate is consumed in the first step. Ethylene or monosulfoaluminate is a more dangerous for the concrete, especially after hardening of concrete. For example, if the concrete product, like concrete structure, after hardening and concrete such structure or such element are in contact with the soil of high amount of sulfate, like SO3 and so forth. In such case, a monosulfonate will return to react. Such phase return to react with sulfate, potassium sulfate in the soil, in the water, like bridges, and forming ethylene diet. Ethylene diet is a very expensive product and make cracks and deterioration in the concrete product. Physical mechanical properties. After hardening, after cement hardening, or the produced cement in the factory must be characterized. The characterization of cement may be chemical characterization, physical characterization, and mechanical characterization. The specifications for cement will set limits for all these requirements, limits for chemical requirements, limits for physical and mechanical requirements. such requirement may be helpful in interpreting the result of cement test. Cement specification or the limits of cement specifications depend on the type of cement. As you know, from the first lecture, several types of cement according to chemical composition or according to performance or degree of performance. The manufacture of cement, during the manufacture of cement, the chemical composition and other physical properties must be monitored periodically. Because any variation, any deviation in the chemical composition, in the physical properties of such cement, the performance of such cement will not achieve its target. So several parameters like finance, setting time, strength, and soundness must be checked critically after the production of any type of cement. Finance here may be by surface area, square meter per gram, or amount of material or amount of grains retained on sieve of opening 45 microns. Setting times were initial or final by decade or Gelman, but the most famous ability is the decade. Strength with the most important factors, most important parameters that such parameter will help us to control or to judge the performance of the produced cement. By comparative strengths, for example, pressure strength, tensile strength, any other type of strength, and strength activity index when we use some other additives like photolana, isolate materials as a replacement additive material for cement. The property number 4 is soundness. Soundness means expansion or contraction. The property of cement, if the cement retain its shape after hydration or its shape shrinkage or expanded after the hydration with water. Some properties related to the chemical composition, we will not speak about it because we throw light on the chemical composition of different types of cement in the first lecture, and in this lecture we will talk about some physical properties of different cement. For Portland cement, according to ESTM C150, the finance by specific surface areas, specific surface, for all type of cement must be minimum 260 meter square meter per kilogram. The soundness, the expansion of all these type of cement must not exceed 0.8%. Must not exceed 0.8%. Soundness or expansion is an indication of the soundness of cement. The other property, comparative strength by meter scale. The result of the comparative strength for all for different type of cement varies according to the composition of the type of cement. From 1 day to 28 days. Setting times, whether initial or final. Setting times must be not less than for initial setting times 45 minutes, and for final setting time must be not less than 375 minutes. The increase in initial setting time is a very important parameter because the initial setting time that are helpful or enable the mixing of the concrete, for example, concrete mixing, transporting, placing, and agitating the concrete. So this time must be must not decrease, must be not less than such number. Also, the final setting value. Other products for blended cement. Blended cement is Portland cement, but mixed with different types of additive material or substitution material like IL or IL meaning limestone additives, IP pozzolanic additive, IT ternary additives. Ternary additives like limestone, Portland, and slag additives. For all these type of cement, the properties are varied, especially for compressive strengths. For soundness and setting time, the values are I think the values are fixed. Expansion, the expansion, the